Hello friends, welcome to Truth of Physics. Today in this particular video, I will discuss on spherical polar coordinate system. In this video, I will discuss this whole concept with proper visualization so that after watching this video, I am sure that we'll get the proper concept of spherical polar coordinate system and you can visualize it easily. And I want to say that this is a very important topic, spherical polar coordinate system, for any physics student, because its application is everywhere, every part of physics. So this is very much important. So this is not very much hard to understand. I will give you proper visualization in this video, so after that you will be able to understand everything very easily. So watch this video carefully till the end, and if you are new, then you can subscribe this channel to get notifications of videos like this. Okay, so I want to show you that in this video I will cover this type of things. And if this video, I want to make a thing clear that if this video's length will be very much longer, this video will be very much longer, then I will separate it into two parts, because first I have to visualize you the things that is related the spherical polar coordinate system, and then I have to derive some very important things, that is unit vectors and the relations from xyz coordinate system to r theta phi coordinate system. Okay, now coming to the main point. In our, suppose this is our x, this is our y, and this is our z. That means this is what? This is the this is the Cartesian coordinate system. Forgot about this sphere. So in our Cartesian coordinate system, there are three coordinates, x, y, z, sufficient. These three coordinates are sufficient to locate any point in 3D space in our Cartesian coordinate system, right? Just focus on the things that I am denoting. Forget about all the things like these lines. Forget about these lines that is shown in this figure. Just focus on this point. Okay, this point. Suppose this point is P. So this can be located with this coordinate is x, y, z in Cartesian coordinate, or in spherical polar coordinate we have also three coordinates, r, theta and phi. Okay, one more thing, that there is another coordinate system that is called our r and theta coordinate system, or plane polar coordinate system, and I have made a video on this topic. Okay, what is plane polar coordinate system and all the formulations, all the formulas in that coordinate system. So I will give the link of the video in the description box. From there you can watch that. Now r, theta, phi. Now how this works, we know pretty well that how x, y and z works in Cartesian coordinate system. We have to go x-axis, along x-axis x distance, along y-axis y distance, and along z-axis z distance to reach at this point. Now in spherical polar coordinate system, what happens? One example of spherical polar coordinate system is our earth. We live in our earth, and our earth is almost a sphere. So we live in a spherical polar coordinate system. To understand the many things like Coriolis force and all the things, we have to understand these concepts. Now just look at my hand. This is, suppose my hand, this is a straight line, or this is a, suppose this is a straight line, suppose. Now this hand is, I am putting this hand here along this line. Then you can easily understand that if this angle, which is my hand, is making an angle 0 degree with the z axis, and when we move the hand slightly, then it will come to, suppose, theta angle, this. Okay, now forget about all the things. Now if we move my hand something like this, tilted, then we will come to the angle theta. And now from point O, this is the origin, suppose O, from point O, if we move toward this angle theta, with making an angle theta with the z axis, and move r distance, then we will come to this point. Is that right? Think about yourself. Can we reach to that point P with only moving r distance? That means this distance is r, this distance is r, this r distance, and this theta, making an angle with the z axis. Can we reach to this point? The answer is no, because the trajectory of this will be a circle. By doing that, we will only come to the trajectories of this circle. How? You can understand it in 3D. This angle is also theta, and when we move along this side of this circle, suppose this point is making an angle in with the z-axis theta. So all the trajectory of this circle, every point of this circle, the angle which is making with the z-axis, the radial vector, that means this vector, is always theta. That means theta is not changing, but we, after doing that, we can get different points, right? These points are not same. This point are not same. That means with these two coordinates, it is not this only the two coordinates is not sufficient to locate a particular point in 3D space. So we need another coordinate, that is called this. This is also called the azimuthal angle, or simply phi. Now what is this angle? This angle is this angle. Okay. So after defining this angle, only we can come to this point, come to this particular point. Okay, good. Now I am just cleaning this and coming to the next point.